Hey everyone, welcome to my channel. Welcome back. In the previous video, we have done up to reactivity towards halogen of the 13th group element, like boron family. Now we'll continue with the important trends and anomalous properties of boron. Let's talk about important trends and anomalous properties of boron. Certain important trends can be observed in the chemical behavior of group 13 elements. The trichlorides, bromides and iodides of all these elements, being covalent in nature, are hydrolyzed in water. Species like tetrahedral MOH4 whole minus and octahedral MH2O whole 6 plus 3, except in boron, exist in aqueous medium. The monomeric trihalides, being electron deficient, are strong Lewis acids. Boron trifluorides easily reacts with Lewis bases such as ammonia to complete octet around boron. Certain important trends can be observed in the chemical behavior of group 13 elements. The trichlorides, bromides and iodides of all these elements, being covalent in nature, are hydrolyzed in water. Species like tetrahedral MOH4 whole minus and octahedral MH2O whole 6 whole plus 3, except in boron, exist in aqueous medium. The monomeric trihalides, being electron deficient, are strong Lewis acids. Boron trifluorides easily reacts with Lewis bases such as ammonia to complete octet around boron. So BF3, it accepts a lone pair of electron from ammonia and completes its octet. It is due to the absence of d orbitals that the maximum covalence of boron is 4. Since the d orbitals are available with aluminum and other elements, the maximum covalency can be expected beyond 4. Most of the other metal halides, example AlCl3, are dimerized. Dimerized means AlCl3 is combining with AlCl3, another AlCl3 through halogen bridging. Example Al2Cl6 will form. AlCl3 plus AlCl3 Al2Cl6 is called dimer. The metal species complete its octet by accepting electrons from halogen in these halogen bridging molecules. So why dimer is forming? Because aluminum wants to expand its octet, right? It wants to expand its octet. So it accepts an electron pair from the halogen. Talking about why boron is unable to form BF6 whole minus 3 ion. Explain. Due to non-availability of d orbitals, boron is unable to expand its octet. Therefore, the maximum covalency of boron cannot exceed 4, right? It cannot exceed 4. Now let's talk about some important compounds of borons. This is the most important part of the boron family. Some important compounds of boron. Some useful compounds of boron are orthoboric acid, borax and diboron. We'll briefly study their chemistry. Borax, it is the most important compound of boron. It is a white crystalline solid of formula Na2B4O710H2O. So we'll simultaneously discuss the important questions. So borax क्या होता है? It is the most important compound of boron. It is white crystalline solid of formula Na2B4O710H2O. So what is borax? Borax is the most important compound of boron. It is white, it is crystalline solid of formula Na2B4O710H2. In fact, it contains the tetranuclear units B4O5OH4 whole minus 2. So it is the most important compound of boron. Borax. It is white, yellow, black, blue, black. What color it is? It is white crystalline solid of formula Na2B4O710H2O. So it is having 10 water molecules. So I was just giving a trick about when you get bored, you drink lots of water, then it is borax. So the borax formula is Na2B4O710H2O. In fact, it contains the tetranuclear unit B4O5OH4 whole minus 2. So it contains a tetranuclear unit B4O5 whole OH whole 4 minus 2, and correct formula therefore is Na2B4O5OH4 8 water molecules. Borax dissolves in water to give an alkali solution. So we think that borax might be an acid, so when it dissolves in water it gives an acid, but borax, when it dissolves in water, it gives a alkaline solution. So borax Na2B4O7, so why it gives see Na2B4O7 7H2, it will form 2NaOH, 2NaOH plus H3BO3, boric acid, and boric acid is a weak acid, right? सिंस बोरेक्स के फॉर्मूला में सोडियम भी है, सोडियम होने के वजह से, सोडियम होने के कारण यहाँ पे सोडियम हाइड्रोक्साइड एक स्ट्रॉन्ग बेस बन जाता है एंड ऑर्थोबोरिक एसिड एक वीक एसिड है, तो इसलिए ओवरऑल सोल्यूशन है बेसिक अल्कलाइन सोल्यूशन. सो Na2B4O7 plus 7 water molecules, NaOH plus H3BO3, boric acid is formed, orthoboric acid is formed. On heating borax, first it loses water molecules and swells up. So on heating borax, first it loses water molecules and swells up. On further heating, it turns into a transparent liquid which solidifies into glass-like material known as borax bead. So on heating, borax first loses water molecules and swells up. On further heating, it turns into a transparent liquid which solidifies into glass-like material known as borax bead. So when you heat, it will lose Na2B4O7 10H2O. It will lose 10 water molecules. Then Na2B4O7 is called sodium metaborate because it swelled up. So how to remember this? So you can just make a trick that when NCERT is saying that borax first loses water molecules and swells up, it means metaborate is formed. Meta means mota, mota means swelled up, right? So sodium metaborate. Then on further heating, it will form a transparent liquid which it solidifies into glass-like material known as borax bead. So NaBO2 will form and boric anhydride B2O3 will form. So NaBO2 is borax bead. The metaborates of many transition metals have characteristic colors, and therefore borax bead test can be used to identify them in the laboratory. For example, when borax is heated in a Bunsen burner flame with cobalt oxide and a loop of platinum wire, a blue colored cobalt CoBO2 bead is formed. CoBO2 bead is formed. It's a blue colored. It's a blue color. So Bunsen burner flame with COO and a loop of platinum wire. Now let's talk about orthoboric acid. Orthoboric acid is H3BO3. Orthoboric acid is H3BO3. It's a white crystalline solid with a soapy touch. So it's a white crystalline solid with a soapy touch. So it has a soapy touch. Orthoboric acid H3BO3 is a white crystalline solid with soapy touch. It is sparingly soluble in water but highly soluble in hot water. It can be prepared by acidifying an aqueous solution of borax. तो बोरेक्स से ही बाकी के बनते हैं, तो बोरेक्स को एसिडिफाई करो, 5 water molecules, NaCl and BOH taken thrice will form. BOH taken thrice means H3BO3. It is also formed by the hydrolysis. It is also formed by the hydrolysis reaction with water or dilute acid of most boron compounds, halides, hydrides, etc. It has a layered structure in which planar BO3 units are joined by hydrogen bonds. So it is also formed by the hydrolysis reaction. It is also formed by the hydrolysis reaction. It is also formed by the hydrolysis reaction with water or dilute acid of most boron compounds, halides, hydrides, etc. So boric acid or orthoboric acid, it has a layered structure in which planar BO3 units are joined by hydrogen bonds as shown. So this part that orthoboric acid has a layered structure in which planar BO3 units are joined by hydrogen bonds is a previous year question. So boric acid is a weak monobasic acid. So this is also a previous year question, that boric acid is a monobasic acid or tribasic acid. So boric acid is a monobasic acid, weak monobasic acid. It is not a protonic acid, do not gives proton, but acts as Lewis acid by accepting electrons from a hydroxyl ion. So BOH thrice is called boric acid, H3BO3 or BOH taken thrice, plus HOH. In that when it takes OH minus from water, and hence H plus ions are released. So on heating orthoboric acid above 370 Kelvin forms metaboric acid. It also forms metaboric acid by losing a water molecule. So H3BO3 is there. So 3 hydrogens are there. So H2O, one water molecule it loses and forms HBO2. When on further heating it yields boric oxide. B2O3 is called boric oxide. It has lost all its water and it formed B2O3. So boric acid has the dotted line represents hydrogen bonds. So it has a layer structure in which planar BO3 units are joined by hydrogen bonds. Okay, why is boric acid considered as a weak acid? Why boric acid is considered, तो ये pink box का question है. Why is boric acid considered as a weak acid? Because it is not able to release H plus ions by itself on its own. It receives OH minus ions from water molecule to complete its octet and in turn releases H plus ions. तो मैं water में से OH minus निकालेंगे तो बचेगा क्या? H plus. तो H plus ions water में से release कर रहा है, खुद का release नहीं कर रहा. ओके अब पढ़ते हैं डाइबोरेन. डाइबोरेन का फॉर्मूला है B2H6. सो दिस इज ऑल्सो अ वेरी इंपॉर्टेंट टॉपिक फ्रॉम दिस चैप्टर. द सिंपलेस्ट बोरॉन हाइड्राइड नोन इज डाइबोरेन. सिंपलेस्ट बोरॉन हाइड्राइड known boron hydride is diboron. It is prepared by treating boron trifluoride with lithium aluminium hydride in diethyl ether. So diethyl ether में बनता है, right? So BF3 plus lithium aluminium hydride, so you will get B2H6 LiF and LF3. A convenient laboratory method for the preparation of diboron involves the oxidation of sodium borohydride with iodine. तो अगर आपको आप सपोज आप एक कंपनी इस्टेब्लिश कर रहे हो, ओके, अ कन्वीनियंट लैबोरेटरी मेथड फॉर द प्रिपरेशन, तो आप BF3 LiL4 के साथ प्रिपेयर कर सकते हो. लेकिन आप लेबोरेटरी में प्रिपेयर करना चाहते हो फॉर द प्रिपरेशन ऑफ डाइबोरेन इन्वॉल्व्स द ऑक्सीडेशन ऑफ सोडियम बोरॉन हाइड्राइड विद आयोडीन. सपोज मुझे आपको डाइबोरेन बनाकर बताना है, राइट, डेमोन्स्ट्रेट करना है, तो मैं क्या करूँगी, लेबोरेटरी में जाऊँगी और डाइबोरेन बनाने के लिए सोडियम बोरो एनहाइड्राइड का ऑक्सीडेशन आयोडीन से करवाऊँगी. सोडियम बोरोहाइड्राइड मतलब NaBH4 और आयोडीन, तो इट विल फॉर्म B2H6 sodium iodide and H2. Diboron is produced on an industrial scale by the reaction of BF3 with sodium hydride. So diboron is produced on an industrial scale. So आपको डाइबोरेन लेना है और उसको इंडस्ट्रियल स्केल में बनाना है by the reaction of BF3. You have to take BF3 with sodium hydride. So diboron is produced on an industrial scale. Suppose आपने कंपनी बनानी है, कंपनी इंडस्ट्री इस्टेब्लिश करनी है, so how can you prepare diboron की इंडस्ट्री? So by the reaction of BF3 with sodium hydride. तो सोडियम हाइड्राइड लेना है और BF3 लेना है, तो B2H6 और NaF बन जाएगा. और अगर आपको लेबोरेटरी में बनाना है तो सोडियम बोरोहाइड्राइड मतलब NaBH4 का ऑक्सीडेशन आयोडीन से करवाना है I2. इट विल गिव B2H6 एंड Na प्लस H2 गैस. H2 गैस बनता है इसमें, तो इट हेल्प्स यू इन द लेबोरेटरी. छोटा अमाउंट, स्मॉल अमाउंट यू कैन गेट H2 गैस. ओके, डाइबोरेन कैसा है? कलरलेस, हाईली टॉक्सिक गैस. अगर मुझे सपोज इंडस्ट्री मैंने इस्टेब्लिश किए तो मैं सो बाई it is a toxic gas, so if you want to kill some animal or something, you can prepare diboron and you can liberate that gas into the particular area, so those organisms will die. So with a boiling point of 180 Kelvin, diborane catches fire spontaneously upon exposure to air. So diborane catches fire spontaneously upon exposure to air. It burns in oxygen, releasing an enormous amount of energy. Suppose I want to burn a grassland, okay? So I can pass diborane gas and it can expose to small amount of fire, then or exposure to air. I can just expose it to air, anyhow it is exposed, and then it burns in oxygen, releasing enormous amount of energy. B2H6 and 3 oxygen, it will form B2O3 plus 3 water molecules. B2O3 is called boric oxide. Boric oxide is also formed when you heat boric acid, then it will form metaboric acid, metaboric to boric oxide. So this way also, by diborane, when you are released in air, it reacts with oxygen and forms B2O3 plus 3 water. So delta H is minus 1976 kilojoule per mole. So large amount of heat is released, enormous amount of heat. So most of the higher boranes are also spontaneously flammable in air. Boranes are readily hydrolyzed by water to give boric acid. So if I want boric acid, so I can hydrolyze it with water, B2H6 with water, it will form BOH taken thrice aqueous plus 6H2. Diborane undergoes cleavage reactions with Lewis bases. So diborane, it undergoes cleavage reactions. So diborane, it undergoes cleavage reactions with Lewis bases to give boron adducts BH3L. So this adduct is important. So अगर आपको डाइबोरेन से you can also form boric acid. How? By hydrolyzing it. But be careful, if you expose it to oxygen, it will catch fire and it will release an enormous amount of heat. So if you hydrolyze it water, you will get boric acid and H2 gas. H2 gas is highly inflammable, right? So be careful. Diborane undergoes cleavage reactions with Lewis bases. So diborane, it undergoes cleavage reactions with Lewis bases to give boron adducts. Boron adducts. Boron adducts. So B2H6 plus 2 and Me3 will form BH3 and Me3. So it undergoes diborane undergoes cleavage reactions with Lewis bases to give boron adducts. Lewis base means what? Lone pair donor, and diborane will accept the lone pair. So B2H6 plus 2 and Me3, it will form 2BH3 and Me3. B2H6 plus 2 carbon monoxide, it will form 2BH3 CO. Reaction of ammonia with diborane gives initially B2H6 2NH3, which is formulated as BH2NH3 taken twice whole plus and BH4 whole minus. Further heating gives borazine. What is borazine? B3N3H6, known as inorganic benzene. What is inorganic benzene? B3N3H6. What is benzene? C6H6. So यहाँ पे हाइड्रोजन तो 6 है, लेकिन 6 कार्बन की जगह 3 बोरॉन है, B3 and N3. Reaction of ammonia with diborane gives initially B2H6 2NH3, which is formulated as BH2 NH3 taken twice whole plus BH4 whole minus. Further heating gives borazine. Borazine is B3N3H6, known as inorganic benzene, in view of its ring structure with alternate BH and NH groups. So further heating, it gives borazine B3N3H6. It is known as inorganic benzene in view of its ring structure with alternate BH and NH groups. So borazine inorganic benzene is planar. Its hybridization is sp2. It is polar. It is soluble in water. So 2B2H6 plus 6 ammonia. First it will give 3BH2 and H3 taken twice whole plus. अब हो सकता है कि and they can frame a question like borazine, when it reacts with ammonia, initially it forms a compound A. On heating it forms borazine inorganic. On heating it forms B, plus dual hydrogen gas. So you have to identify A and B. So BH2, दो BH2 और दो अमोनिया. Ammonia means NH3. So BH2 और दो अमोनिया, NH second twice whole plus का चार्ज, और BH4 whole minus. तो हो गया ना B2H6, BH4 whole minus. So this is first initial product. And further heating it will give you borazine. The structure of diborane is shown in figure 1.2a. The structure of diborane B2H6. The 4 terminal hydrogen atoms and the 2 boron atoms lie in one plane. So now they can frame a question like, how many atoms in diborane are in a one plane? So how many atoms? 6. How 6? 2 hydrogens, terminal hydrogens HT I am writing, and 2 boron atoms. Above and below this plane there are 2 bridging hydrogen atoms. 2 bridging hydrogen atoms. The 4 terminal BH hydrogen atoms. The 4 terminal BH bonds are regular 2 center 2 electron bonds, with the 2 bridge BHB bonds are different and can be described in terms of this 3. So the 4 terminal hydrogen atoms and the 2 boron atoms lie in one plane. Above and below this plane there are 2 bridging hydrogen atoms. 2 bridging hydrogen atoms होते हैं. The 4 terminal BH bonds are regular 2 center 2 electron bonds, while the 2 bridge BHB bonds are different and can be described in terms of 3 centered 2 electron bonds. So one thing you need to remember that कि जो diborane होता है उसमें 3 centered 2 electron bond होता है. 3 centered 2 electron bond. One more thing is जो diborane होता है इसमें 6 atoms plane में होते हैं. 4 terminal hydrogens और 2 boron atoms. और जो plane में नहीं होते वो कौन से हैं? 2 hydrogens, राइट. सो जो 2 hydrogens हैं, एक हाइड्रोजन और 2 बोरॉन के ऑर्बिटल्स, BHB बॉन्ड बनता है. द प्रॉब्लम विथ इट इज, क्वेश्चन कैसे बनता है? क्वेश्चन बनता है कि हाउ मेनी boron bonds are there? BB bonds. So there are no BB bonds, there are only BHB bonds. There are 2 BHB bonds, BHB, and there are 2 BH bonds, 4 BH bonds. There are no BB bonds, there are only BHB bonds, BHB and BH bonds. Boron also forms a series of hydridoborates. The most important one is the tetrahedral BH4 minus ion. So जो boron है, it also forms a series of hydridoborates. The most important one is the tetrahedral BH4 whole minus ion. BH4 minus ion जब हम हीट कर रहे थे किसको, वो डाइबोरेन को, तो बना था एज इंटरमीडिएट BH4 माइनस. तो boron also forms a series of hydridoborates. इसको बोलते हैं hydridoborates. The most important one is the tetrahedral BH4 whole minus. Tetrahydridoborates of several metals are known. Lithium and sodium tetrahydridoborates, also known as borohydrides. क्या बोलते हैं? Borohydrides. Lithium and sodium tetrahydroborates को tetrahydridoborates are prepared by the reaction of metal hydrides with B2H6 in diethyl ether में काम करता है. So 2MH LiH हो सकता है, NaH हो सकता है. B2H6 will form 2M plus BH4 minus. M क्या है? लिथियम या फिर सोडियम. सारे अल्कली मेटल्स नहीं. सो क्वेश्चन ऐसे बन सकते हैं, लिथियम और सोडियम देकर एनसीईआरटी में क्वेश्चन बन सकते हैं कि विच ऑफ द फॉलोइंग अल्कली मेटल्स कैन फॉर्म बोरोहाइड्राइड्स. ऑप्शंस है कि ऑप्शंस क्या हैं? लिथियम, सोडियम, पोटेशियम, ऑल. लिथियम, सोडियम, पोटेशियम, ऑल, एंड फिफ्थ ऑप्शन भी ले लेते हैं, लिथियम एंड सोडियम. सो आंसर क्या होगा? लिथियम एंड सोडियम. सारे नहीं बनाते. सो या फिर स्टेटमेंट टाइप क्वेश्चन भी आ सकते हैं. Lithium and sodium tetrahydroborates are also known as borohydrides. These are prepared by the reaction of metal hydrides with B2H6 and diethyl ether. Third option आ जाएगा all the alkali metals form borohydrides. Fourth option only lithium and sodium forms borohydrides. So what will be the answer? Identify the incorrect statement. That will be the third statement. कि सारे नहीं बनाते, सिर्फ लिथियम और सोडियम ही बनाता है. तो यहाँ पे बनाना बॉन्ड बनता है. तो देखते हैं बॉन्डिंग इन डाइबोरेन. ईच बोरॉन एटम यूजेस sp3 हाइब्रिड्स फॉर बॉन्डिंग. कौन सा हाइब्रिडाइजेशन होता है बोरॉन में? sp3 हाइब्रिडाइजेशन. ये याद रखना है. sp3 हाइब्रिडाइज्ड 4 ऑर्बिटल्स बनते हैं ऑन ईच बोरॉन एटम. वन इज़ विदाउट एन इलेक्ट्रॉन शोन. देखो हाइब्रिडाइजेशन में हर टाइप के ऑर्बिटल्स हाइब्रिडाइज हो सकते हैं. एक होगा नॉर्मल जिसमें इलेक्ट्रॉन है, अनपेड इलेक्ट्रॉन. एक होगा जिसमें लोन पेयर है. एक होगा जिसमें कोई इलेक्ट्रॉन नहीं है, एम्प्टी ऑर्बिटल. तो ये भी हाइब्रिडाइजेशन में पार्टिसिपेट कर सकते हैं. तो वन इज़ विदाउट एन इलेक्ट्रॉन शोन इन द ब्रोकन लाइन्स. द टर्मिनल BH bonds are normal 2 centered to electron bonds, but the 2 bridged bonds are 3 centered to electron bond. The 3 centered to electron bridge bonds are also referred to as banana bonds. तो यहाँ पे banana bonds मिलते हैं. So banana bonds यहाँ पे मिलते हैं. So banana bonds क्या है? 3 centered to electron bonds. Both lithium borohydride and sodium borohydrides are used as reducing agents. So both lithium borohydrides and sodium borohydrides are used as reducing agent in organic synthesis. They are useful starting materials for preparing other metal borohydrides. So lithium borohydride, sodium borohydride ये reducing agent की तरह यूज़ करते हैं in chemistry, organic chemistry. जैसे कि NaBH4 हम देखते हैं. They are used as starting material for preparing other metal borohydrides. Okay. So let's come back to that page and see the angles and bond lengths. So diborane is having 4 terminal hydrogens, 2 bridged hydrogens, right? So if we talk about one boron atom is having 2 terminal hydrogens. Okay, so the bond angle of boron is 97 degrees. If you see between the banana bonds BHB वाला, तो there you can see that 1 2 3 1 2 3 4. So 4 are there. So 97 degrees and 120 degrees in the outer side. Okay, inner side उसको strain होगा तो वो 97 degrees, बाहर 120 degrees. और यहाँ पे 119 पिकोमीटर होगा. और जो डॉटेड लाइन से बना हुआ है दैट इज़ लाइक बनाना बॉन्ड का जो है वो छोटा होगा. बनाना बॉन्ड विल बी मोर बड़ा होगा, 134 पिकोमीटर. दैट इज़ 119 पिकोमीटर. इट इज़ 119 पिकोमीटर. इट इज़ 134 पिकोमीटर. सो बनाना बॉन्ड का बॉन्ड लेंथ बड़ा होगा. एंड इफ़ यू टॉक अबाउट BHB बॉन्ड एंगल, सो यहाँ पे 97 डिग्री स्ट्रेन होगा उसको, राइट, और वो 120 डिग्रीज. नाउ लेट्स टॉक अबाउट यूजेस ऑफ बोरॉन एंड एल्यूमिनियम and their compounds. This will be the last topic. Boron being extremely hard refractory solid of high melting point. So boron being extremely hard refractory solid of high melting point, low density, very low electrical conductivity. तो इसकी डेंसिटी कम है. मेरा हम जब 1s2s पढ़ रहे थे तो फर्स्ट एलिमेंट की डेंसिटी बहुत ज़्यादा थी, यहाँ पे डेंसिटी कम है. एंड वेरी लो इलेक्ट्रिकल कंडक्टिविटी बहुत कम है. फाइंड्स many applications. Boron fibers are used in making bulletproof vests and light composite materials for aircrafts. So if you gone into a fight, if you have indulged into some fight in the like Ukraine and Russia fight, so you must have boron fibers so that you can make bulletproof vest and light composite materials for aircraft to fly off to India, right? So you need first bulletproof vest, boron fibers and light composite materials for aircraft. The boron, the boron 10 B10 isotope has high ability to absorb neutrons. So boron 10 isotope has high ability to absorb neutrons. Boron 10 isotope has high ability to absorb neutrons. So boron 10 isotope has high ability to absorb neutrons. It has a high ability to absorb neutrons. Boron 10. Boron 11 is most common. Boron 10 is about around 20%. So it has high ability to absorb neutrons, and therefore metal borides are used in nuclear industry as protective shields and control rods. एज कंट्रोल, ये न्यूक्लियर फिजिक्स में हम पढ़ेंगे कि जो बोरॉन के बोराइड्स होते हैं या फिर बोरॉन होता है आर यूज्ड इन न्यूक्लियर इंडस्ट्री एज प्रोटेक्टिव शील्ड्स एंड कंट्रोल रॉड्स बिकॉज दे absorb the neutron fast moving neutrons, and also they absorb all the neutrons so that it does not come out and cause any problem to humans, to us, right? The main industrial application of borax and boric acid is in the manufacture of heat resistant glasses. Example Pyrex, ग्लास वूल एंड फाइबर ग्लास. तो हमने देखा था कि बोरेक्स और बोरिक एसिड, अगर आपको इंडस्ट्रियली बोरिक एसिड बनाना है तो कैसे बनाओगे इंडस्ट्रियली बनाना है तो आपको क्या करना पड़ेगा, बोरान ट्राइफ्लोराइड को BF3 को सोडियम हाइड्राइड NaH के साथ रिएक्ट करना पड़ेगा, तो आपको डाइबोरिन मिलेगा, राइट, डाइबोरिन मिलेगा, राइट. सो डाइबोरिन का डिस्कस किया था हमने. सो जो बोरेक्स और बोरिक एसिड है इज इन द मैन्युफैक्चर ऑफ हीट रेसिस्टेंट ग्लासेस, जैसे कि पायरेक्स ग्लास वूल एंड फाइबर ग्लास. तो ये सब बनाने में हमें बोरेक्स और बोरिक एसिड की ज़रूरत पड़ती है. पायरेक्स मीन्स हीट रेसिस्टेंट ग्लासेस होते हैं, उसको पायरेक्स बोलते हैं. ग्लास वूल एंड फाइबर ग्लास. बोरेक्स इज ऑल्सो यूज्ड एज फ्लक्स फॉर soldering metals. Borax is also used as a flux for soldering metals. For heat, scratch and stain resistant glazed coating to earthenwares, and as constituent of medicinal soaps में तो सब बोरेक्स होता है. An aqueous solution of orthoboric acid is generally used in माइल्ड एंटीसेप्टिक की तरह भी यूज़ करते हैं. तो अब तक हमने एंटीसेप्टिक 1A से हम नोट करें एंटीसेप्टिक क्या क्या होता है. तो वन थिंग इज़ मैग्नीशियम कार्बोनेट, दैट इज़ तो टूथपेस्ट में होता है. ए सस्पेंशन ऑफ मैग्नीशियम हाइड्रोक्साइड इन वाटर, दैट इज़ कॉल्ड मिल्क ऑफ मैग्नीशियम, इज यूज्ड एज एंटासिड. या एंटासिड की तरह यूज़ होता है. अनदर थिंग इज़ ऑर्थोबोरिक एसिड इज़ जनरली यूज्ड एज माइल्ड एंटीसेप्टिक. तो एक्वस सोल्यूशन में ऑर्थोबोरिक एसिड इज़ यूज्ड एज माइल्ड एंटीसेप्टिक. इवन हमने देखा था कि कैल्शियम के भी यूज़ होते हैं एज माइल्ड एंटीसेप्टिक. सो एक्वस सोल्यूशन जो होता है किसका, बोरिक एसिड का. एक्वस सोल्यूशन ऑफ बोरिक एसिड, एक्वस सोल्यूशन ऑफ बोरिक एसिड is used as antiseptic. Aqueous solution of boric acid is used as antiseptic. Aluminium is a bright silvery white metal with high tensile strength and has a high electrical and thermal conductivity. So aluminium क्या होता है, bright silvery white metal. तो एकदम वाइट ब्राइट मेटल होता है सिल्वर कलर का, विथ हाई टेंसाइल स्ट्रेंथ, अच्छी खासी होती है. इट हैज़ अ हाई इलेक्ट्रिकल एंड थर्मल कंडक्टिविटी. ऑन अ वेट टू वेट बेसिस द इलेक्ट्रिकल कंडक्टिविटी ऑफ एल्यूमिनियम इज ट्वाइस दैट ऑफ कॉपर. सो ये इंपॉर्टेंट पॉइंट है कि अगर आप वेट का चेक करो, जैसे कि मैंने 10 ग्राम्स ऑफ एल्यूमिनियम ले लिया और 10 ग्राम्स ऑफ कॉपर, और उसमें कंडक्टिविटी चेक करी, तो सेम वेट का अगर हम लेते हैं तो एल्यूमिनियम की कंडक्टिविटी 2 गुना ज़्यादा है कॉपर की कंडक्टिविटी से. एल्यूमिनियम इज़ यूज्ड एक्सटेंसिवली इन इंडस्ट्री एंड एवरीडे लाइफ. इट फॉर्म्स एलॉयज विथ कॉपर, मैंगनीज, मैग्नीशियम, सिलिकॉन, जिंक. इन सब के साथ ये एलॉय बनाता है. तो कॉपर के साथ एलॉय बनाता है, मैंगनीज, मैग्नीशियम, सिलिकॉन, जिंक. तो इन सब के साथ एलॉय बनाता है, एलॉय. सो कॉपर के साथ मैंगनीज, मैग्नीशियम, सिलिकॉन, जिंक. and its alloys can be given shapes of pipe. तो पाइप एल्युमिनियम के बने होते हैं. ट्यूब्स, रॉड्स, वायर्स, प्लेट्स और फॉइल्स. पाइप होता है, ट्यूब होता है, रॉड होता है, वायर, प्लेट्स और फॉइल्स, एल्युमिनियम फॉइल्स जो हम बहुत यूज़ करते हैं. एंड देयरफॉर फाइंड यूजेस इन पैकिंग, यूटेंसिल मेकिंग, कंस्ट्रक्शन. यूटेंसिल्स भी एल्युमिनियम के बने होते हैं, बट इट्स नॉट advisable to cook in that utensils, aluminum utensils, because in aluminum utensils what happens is they look good, but they are non-sticky type, but what happens with aluminum is small amount of aluminum mixed with our food and it get deposited in our body, which causes lot of metabolic problems. So it's very harmful. Aluminum and its alloy can be given shapes of pipe, tube, rod, wires, plates or foils, and therefore find uses in packing utensil making, construction, aeroplane and transportation industry. The use of aluminum, its compounds for domestic purposes, is now reduced considerably because of the toxic nature. So NCERT is also saying that its use is decreased now because it causes a lot of toxic nature. It has, but still many people in India, they use this aluminum cookers, aluminum vessels, aluminum bottles and all, but it causes toxic effect. And if you see, one thing is, if you buy a aluminum utensil and use it for years, and then when you check its weight is reduced, it means that some of the aluminum is gone into our food, and it, as we have consumed, it has gone into our stomach and is causing a metabolic problems, and it's not safe. It has toxic nature. So by this we have covered each and every line of NCERT with some important questions, and let's meet in my next video. Till then, subscribe to my channel, and I'm signing off. Thank you so much for your time.